Okay, so I've made some strips of paper and I'm going to measure them and then turn them into circles. So first of all, let's measure this first one. I'm making that 12.7, and then that gives me a circle, if I just try and get it nicely end to end without any overlap, of well, it's just about 4, trying to get it as round as possible there. About 4.3 I'm getting for that. So 12.7 and 4.3. So if I take that circle, the length of that piece of card that I've made it from is the circumference. It's the distance all the way around the edge of the circle. So putting that in my table, a circumference of 12.7 and the diameter was 4.3. It was all the way across. So I'm going to do that for a few of these. This one here. So that one I'm getting to be, I'm going to call that 17.2. So that makes a circle with a circumference of 17.2 once I wrap that up. And then let's see what the diameter of that comes out to be. So try and get it as round as possible and measure it at the widest point. Yeah, I'm making that about 5.5. It's very imprecise, but if a lot of people do this, then we should start to see some kind of pattern to this. Okay, so this one's 22.5. So if I roll that up into a circle, it's got a circumference of 22.5. And let's see what kind of a diameter we get for that one. So just stick it end to end. Try and get it as round as possible. I'm making that very difficult to get it exact, but I'm making that about 7.4. 7.4. And then one more. Okay, this one's 29 point, I'm making that 29.6 centimeters. So 29.6 centimeters for a circumference when I roll it up. And then let's see what that's giving me in the circle. So again, a little bit on the imprecise side, but maybe 9.9 I'm getting for that. Okay, so very, very rough and slapdash with the measuring there. But I'm going to do circumference divided by diameter. So I'm going to see each time how many times the circumference is bigger than the diameter. So just do a little spreadsheet formula here. That one there is going to equal that one divided by that one. Okay, so about 2.95 for that. Let's do the same thing again. That one equals that one divided by that one. 3.12, okay. That one equals that one divided by that one. 3.04, and that one equals that one divided by that one. Okay, so just under 3. So we're kind of seeing that, roughly speaking, the circumference of a circle is about 3 times as big as the diameter. So the circumference there, when you unwrap it all the way around the edge, about 3 times as big as the distance across. And then you should expect that result to be more or less the same every time, because of course all circles are exactly the same as each other in terms of their shape, so they're all similar to one another mathematically. So if we expect one circle's circumference to be about 3 times as big as its diameter, we would expect that for all circles. Okay, so we're going to take some class notes about what we've just done. So we need to write down in our books circles for a heading. Then we measured the diameter and circumference of some circles. Then a little diagram there reminding you that the diameter is all the way across the middle and the circumference is all the way around. So then there's our table of values with circumference and diameter and circumference divided by diameter. Then we observed that the circumference was typically about 3 times as big as the diameter. So in fact, you can try this yourself. So copy out the table neatly and then do a few more with strips of paper and measure them yourself and see what results you get for circumference, diameter, and circumference divided by diameter. So when you've done all that and got this written down, you can carry on, but in the meantime, pause the video. Okay, so moving on, we need to write down that since all circles are basically the same shape, or they're similar, to give it the proper mathematical term, then circumference divided by diameter ought to give the same result every time. And in fact, if we could do this completely accurately, we would get that circumference divided by diameter is 3.14159265358897, and in fact that number goes on forever without any recurring or repeating pattern. And that number is called pi. So all it is just a Greek letter, the letter of the Greek alphabet that's equivalent to the English language letter P. So it's just the lowercase symbol of the letter that makes a P sound, a P sound in the Greek language. So it's pronounced pi in the English language, and it stands for this number 3.14159265358979, and that goes on forever without any repeating pattern. So just pause the video there, get those notes down neatly in your book, and then when you're ready, move on. So something I like to do in class every year is my tournament of pi. See how much you can remember, and then sometimes I give a nice prize that might be pie related. It might be an apple pie or something like that. So I don't expect you to write all of this down in your book. If you like, you can take a screen grab of it, print it out, stick it in. But just have a few digits of pi in your book to remind yourself that the number is something that goes on forever without repetition. The important thing, of course, is that everybody remembers that it's around 3.14. If everybody does that, then I'm getting what I want out of this.